Hi, we are going to do our presentation under the topic NIE-based classification in spam detection. So here we have done a systematic review under this topic. Throughout this presentation, we are going to talk about the introduction related to our topic and the methodology, literature review, gaps and the findings, and the final conclusion. First, the introduction spam detection. So, it is a kind of process of identifying and filtering unwanted emails. And it is a critical aspect of maintaining and clean and efficient email system. So, among various methods employed to tackle this problem, the NIBLAZE classification has gained a significant attention due to its simplicity and also due to its effectiveness. So, in this review article, the we are going to talk about the applications of these knife-based classification under the spam detection and highlights its strength and identifies existing gaps and discuss the recent findings. So knife-based classifier. First, we will look into what is this knife-based classifier. So it is a kind of probabilistic machine learning model based on Bayes theorem and which provides straightforward way to classify data based on prior knowledge and the likelihood of features. So, due to its simplicity, it performs well in text classification tasks, including spam detection. So here is the simple structure of the methodology what we did. So we searched data from the reputed databases like IEEE, ACM, Google Scholar, and Scoopers, and we use these kind of keywords to search. And also we included our inclusion as well as our exclusion criterias like this.
Now let's move on to the literature review. And when it comes to the defectiveness of naive base in spam detection, recent studies confirm the effectiveness of naive base classifiers in spam detection, especially with large data sets. For an example, naive base classifiers achieved accuracy rates between 88% and 93% in spam filtering tasks, and also naive base performs competitively with more complex algorithms like SVM in terms of accuracy and processing speed. When we talk about the refinements in naive Bayes algorithm, a multinomial naive Bayes (MNB) is noted for superior performance in text classification compared to Gaussian and Bernoulli variants. Use of future selection techniques like information gain and TF-IDF weighting improves classification accuracy by filtering out irrelevant features. And when it comes to the challenges with dynamic spam and imbalanced data sets, spammers evolve tactics including text obfuscation and random insertion, which can degrade naive based performance. Methods like smooth and cost sensitive learning are explored to address class imbalance and improve effectiveness. And when we talk about hybrid models and assemble models, hybrid approaches combine naive based with SVM enhanced classification accuracy and manage complex spam patterns more effectively. And assembly methods such as integrating naive base with random forest and adaboost improve accuracy and handle evolving spam tactics. Then, when it comes to handling non-English spam and multimodal content, the knife base can be adapted for multi-language spam detections with proper pre-processing, achieving satisfactory results across different languages. And text-based knife base struggles with multi-modal spam like images, videos. Additional adaptation on integration with other classifiers is needed.
Next, we are going to talk about the gaps and findings of our research. First one is imbalanced data, right? So an imbalanced data set occurs when one class is significantly more than frequent than the other, and in the context of spam detection, so this means there are usually many more legitimate emails compared to spam email. So this imbalance can affect the performance of our classifiers. So the naive based classifiers are popular for their simplicity as effectiveness, as I mentioned earlier, in the spam detection. So, however, when dealing with the imbalanced data set, their performance can be compromised. So, since these models are designed to calculate probabilities based on the feature frequencies, an imbalance can lead to biased predictions, and where the classifiers might favor the majority classes and miss out the detecting spams effectively. So, despite the importance of this issue, there are only a few studies that specifically address how the imbalancedness of these data sets impact the performance of the naive-based classifiers in the spam detection. So, most research has focused on general performance without considering this issue, like the issue is the imbalanced data set. Next one is you know that Naives is known as its simplicity and the efficiency. So while SVM and the deep learning models offer advanced capabilities in handling complex data and learning uh, intricate patterns. So, more research is required to explore how these methods can be effectively integrated, and we need to determine the best strategies for combining these classifiers and understand how they complement each other's in related to the strength and their weaknesses. And also comparative studies are crucial to evaluate this efficiency of these hybrid models. So here it is also a kind of research gap that we identify the hybrid models. So such studies will help to establish effective frameworks for combining different techniques and guide us to developing superior spam detection systems. So the next one is non-English, right? So the most of the research on I-based classifiers focus on English language spam. So this leaves a gaps when it comes to handling spam in other languages. The ability of these classifiers to work effectively with with non-English content and different grammatical structure is still unexplored. That one is also another kind of gap that we identified. Secondly, the text-based naive-based models that struggle with multi-model spam, which include not just text but also images and also the videos, right? So the since all these models are primarily designed for the text analysis, so they have difficulties in dealing with the rich and the diverse content found in the multimodal spams. So in related to that, to address these issues, so we need more research to adapt naive based classifiers for a variety of languages and to handle different types of spam content beyond just text. So by expanding the research, so I hope we can develop more and robust and the versatile spam detection systems. Next one is expandability of naive-based classifier. So that is also we need to expand the performance of these naive-based classifiers. And also other thing is the privacy concern. So as we work to improve spam filters, we must also protect our user privacy. So that has led to the development of privacy preserving machine learning techniques. And one major challenge in the privacy or the utility trade off, so it is essentially we want our spam detection system to be effective. So we also need to ensure that they don't compromise user privacy. For the naive based classifiers, which are commonly used for the spam detection, this trade off hasn't been explored yet. And the final the conclusion what we can have under this research is, so there are several strengths of the naive spam detection. They have highly effective and efficient classifying for the spam emails, and they have high accuracy and the rapid processing time also, and this is suitable for real-time email filtering systems. And also there are some kind of multi nominal naive which enhance the performance. And also they have the feature selection techniques for the further improvement of the accuracy. So in related to the limitation of the naive classifier, there are some challenges in handling feature correlations and difficulty in adapting to the evolving tactics, and the limited effectiveness in processing multimodal or the non-English spam.